the way, you should always use safety goggles.
Alright, so we have the length corrected to match the patella bars. The trim lines on this other prosthesis, which was not made by us, are a little higher medial-lateral, but you can see the patella bars are the right height. Okay, now we're ready to assemble this. Now in this case, alright, now we have the prosthesis cut to the appropriate length. And in this case, this patient is not very active, but we made this prosthesis out of 3/16 material to dramatically reduce the weight of the prosthesis. This limb will be about 1.5 pounds when it's finished. But we wanted to make it a little bit more rigid because his existing system is very rigid, and I didn't want this too flexible. So we elected to go with 3/16 material and an EndoFlex. The EndoFlex is a solid nylon rod that's threaded on one side, I don't know if you can see that, Frank, to 3/8/16. So the idea is that this will thread right down on top of the foot clamp and then sandwich in between the pylon walls and stiffen up the entire system. That's how the rod comes. It comes in an 8.5 inch length, and what you want to do is cut it down to the appropriate length before you install it. It should terminate somewhere in the conical area. It shouldn't terminate down here. It's got to terminate somewhere in the conical area, because if the EndoFlex terminates below the conical area, it's going to put a lot of stress right in this area here. So you want it to extend all the way up into the conical region somewhere. Now, if you're using suction, make sure that it doesn't extend too much, because now your shuttle lock with a pin will end up hitting on the EndoFlex and preventing the patient from going in deep enough. Okay, so we're going to put this one in. This one has been shortened. Okay. Now, what you want to do is screw it down nice and tight. Then you slip the pylon over. Actually, before we do that, I want to show you another thing. The foot clamp has 3/8 of an inch of material between the place where the pylon enters inside the socket to the proximal edge of the prosthetic foot. So there's your 3/8 of material. The total length of the foot clamp is 1 5/8. I'm sorry, is 2 inches. So that leaves us with 1 5/8. We have a very high-tech tool here, tongue blade, measuring out 1 5/8. And what you do is you take and mark 1 5/8 on the pylon. And the reason why you do this is because you cannot see how deep the pylon is into the foot clamp. You want to make sure that it's all the way down and pressing against the bottom surface of the foot clamp. So we've marked it posteriorly, then you slide it in, and it's all the way in. My mark has disappeared. In fact, there it is right there. See? So now I know I'm positively down on the bottom of this foot clamp. Okay? It's assembled, ready to fit the patient. Now, when the time comes to fit the patient, all your adjustments are done on the anterior dynamic alignment or fitting screw. These 2 posterior screws are used only after you've thrilled with the alignment between the pylon and the foot clamp. You don't touch these. In fact, I even remove them and let the patient go on the prosthesis for a while, and when they're satisfied and I'm satisfied with the alignment, at that point we put them in and do the finish. Don't put these in until you're thrilled with the position, the relationship between the pylon and the foot clamp, because if you do, you're going to have a series of useless holes across the back of the pylon, which will make it very unstable. Okay, and there you go. You still got some degree of flexibility, but it's pretty stiff now. And I think that's it. Anything else that I miss? Okay, another issue that's pretty important is, if you notice the union or the seam posteriorly, the screws, the posterior set screws are stainless steel, and they're designed to sandwich that seam and help support it. So you really don't want to be assembling it with the seam off to the side. The idea of these 2 screws is not only to keep the pylon firmly attached to the foot clamp, but also to sandwich the seam and protect its integrity. So if you're finding that the seams aren't landing where you want them to, that's something you have to address during the forming stage. Make sure that your seams are landing in line with the line of progression so that they end up in the middle between these screws somewhere. Okay? And that's ready. Alright, now this prosthesis has now been fit and dynamically aligned, okay? This patient is happy with the prosthesis, but we have to finish up the EndoFlex process to make the prosthesis not only more rigid but also more durable. What we found was that even after the installation of the EndoFlex, we were having patients come back with the foot bolt broken between the top of the foot clamp and the EndoFlex itself. The nylon survives all of it, but the foot bolt would break. And we realized that the reason why was because if you imagine my fingers as the walls of the pylon and the EndoFlex inside, as the patient was walking, this is what was happening. Okay? This was all twisting and torquing on the EndoFlex. So where is the stress? The stress is right at the joint between the EndoFlex and the foot clamp. So the way we resolve that is by eliminating the movement between the EndoFlex and the pylon. And the way we do that is with a number 10 stainless steel screw that comes with the EndoFlex. There are a pair of them that come in. And what you want to do is drill through the pylon wall and the EndoFlex all the way through with a pilot hole, because this screw is too large to drill to tap right into nylon. So we're going to drill this with a pilot hole on both sides. Now as you do it, first of all, also you want to have one a little bit higher than the other one so that they don't crash as they're going through the pylon. Okay? So you drill this through. Okay. And then of course we'll change a bit. I love these keyless chucks. Yeah, that'd be nice. Been doing it that way for years, yeah. You know. Finally they realized. Okay, then you want to install this. Do that on both sides, and now this prosthesis is even stiffer and much more durable, because now we're preventing the EndoFlex from sliding inside the pylon walls of the EndoFlex itself. And that's complete. Now, if you have a patient who's so active and so big that even this isn't enough for him, what we do at times is after we go through our dynamic alignment stage, Eric, Mark, do you have one of those little weird shaped cutoffs from the EndoFlexes in the bin by the bandsaw? We take a scrap piece of copolymer, heat it up in the oven, disassemble it from the foot. So now you have your pylon and foot clamp already screwed together, everything's finished. And then we take a hot piece of copolymer and wrap it over the entire affair, all the way up to here, over the foot clamp and everything. Nah, you know what? It's a cutoff from. I'll get it. If you recall, the scrap piece off the 2x4 sheet, this is what you end up with, is waste like this. So what we can do is, if you have a patient that's, say, 300 pounds and very active, and you're afraid he's even going to break this, only in those cases. It's not really necessary unless you have real heavyweight active patients. What we do is disassemble a foot from the foot clamp, leave the foot clamp on the pylon, leave the EndoFlex in, and sometimes I'll even take a couple more sheet metal screws and screw them in, leaving them exposed a little bit for a mechanical bond between this material after it's hot and the prosthesis itself. So then what you do is you mount this, take this piece, put it in the oven, and when it's hot and you know, at forming temperature, take it and wrap it over the whole thing. Wrap it around a few times, squeeze it with some gloves, even wrap it with an ace bandage, and then pull the ace bandage off before it cools, otherwise it's on there for good. And once you've wrapped the whole system with this piece of scrap, you can actually trim it down and polish it down into a shape that you like. But I have not had one failure when utilizing that system. I have patients, well, let's see, Cunningham is 320 pounds and very active. He hasn't been able to break a prosthesis in 3 years using that method. He has broken them even using this method. But if you find they break them even after you've done all this, this is the next step. And this, of course, will make the prosthesis more rigid as well.